Hello everyone. In this video we will discuss about the concept of formal charges. Now formal charges is an idea that will help us in understanding how the valence shell electrons are basically shared between the atoms in a molecule. Okay, so this is a concept that is based on the covalent bonding which we will derive by looking at the Lewis structures. Okay, but nowadays more than the formal charge, right, in terms of understanding of how the electrons are shared between the atoms, we use the concept of oxidation number or oxidation state. So oxidation number or oxidation state, right, this is the concept that is more relevant nowadays. But the oxidation number and oxidation state concepts we will study in the redox reaction chapter, but here we will look at the idea of the formal charge. Formal charge is something that we will derive based on the Lewis theory or the Lewis dot structures. So in Lewis dot structures, right, we have mentioned one thing particularly, that the Lewis dot structures, they do not represent the actual shapes of the molecules. So Lewis dot structures, they don't represent the actual shapes of the molecules. They only indicate how different atoms are bonded to each other in a molecule. Like say for example, if you talk about the ammonia, right, it tells us how the 3 hydrogens are bonded to nitrogen. That's it. Okay, so and after that the nitrogen will be having 2 electrons, which will be the lone pair. Okay, so this is what we have as the Lewis diagram. So Lewis diagrams of both the molecules as well as ions, right, they only depict how these atoms are bonded within that molecule or the ion. Now even when it comes to the charge species, we have seen the Lewis diagrams for the polyatomic ions. What we will mention is the overall charge will be possessed by the ion or the entity as a whole. Like if you remember the ammonium ion, right, how do we depict? So nitrogen is forming 4 bonds, one with each of these hydrogens, and overall there will be a unit positive charge. So this is what we look at as the structure of the ammonium ion. So we will indicate the total charge on the entire entity and not on the respective atoms. If we look at the concept of formal charge, how we are going to get the concept of formal charge? The formal charge concept we will derive based upon the idea of covalent bonding only. So we are going to derive the concept of formal charge based on the idea of covalent bonding. So here it is not going to be the transfer of electrons like the way we will talk in the case of the ionic bonding or the electrovalent bonding. So there will be no transfer of electrons, nothing of that sort. The formal charge that we are going to derive will be based upon the covalent bonding concept only. We will see how we will get the formal charge, we will see. But what is the main idea of the formal charge? The main idea of the formal charge is it will help us to keep a track of the valence electrons. So the formal charge will be able to help us in keeping a track of the valence electrons, how different atoms are contributing for the bonding in a molecule or an ion. So that is what we will be able to know once we have the formal charges. So we look at the examples. First we look at how do we calculate the formal charge, then we look at the examples, and then we will see what is the significance of this formal charge. So we will begin with what is the formula for the formal charge. Look at the formula for the formal charge. It's a very straightforward formula. Formal charge based upon a particular atom. So here we are going to calculate the formal charge for each and every atom in the molecule. Like that we can calculate. For any atom, the formal charge will be the total number of valence electrons of the atom in the free state. That is basically what the atomic number of the particular atom, minus total number of non-bonding electrons, means the electrons that will be associated with the lone pairs, non-bonding, we have to subtract. Like in the case of say ammonia only we will take, because this is a molecule that we are like very much studying, isn't it? So here what do we see? The nitrogen is bonded to 3 hydrogens. Nitrogen, what is the number of valence electrons? 5. So the formal charge on the nitrogen we will try to calculate. So formal charge will be what? The number of valence electrons of that particular atom, nitrogen, in the free state. What is it? 5. Minus the number of non-bonding electrons. Look at this. How many non-bonding electrons are there? 2 are there. Minus half the times the number of bonding electrons. Bonding electrons will come from where? Shared pairs. See, here we have 2 electrons shared, here we have 2 electrons shared, here we have 2 electrons shared. Totally what is the number of shared electrons? 6. So 2 ones are, 2 threes are, what is it? 5 minus 2 minus 3, what is it? 0. So in ammonia the formal charge on nitrogen is what? 0. So this is how we are going to get the formal charge. It is not like, you know, always we'll have the formal charge on the atoms to be 0. We'll have the formal charge values also. It can be sometimes positive, it can be sometimes negative. We will look at the ozone. See, ozone, right, is a molecule where we see that there is a coordinate covalent bond. So if you number these oxygens, right, oxygen 1 is the central oxygen, 2 and 3 are what? The peripheral oxygens. We will have a coordinate covalent bond between the oxygen 1 and oxygen 3. Now if you look at, right, so here there is one shared pair, another shared, double bond, right? Double bond means what? There are 2 shared pairs of electrons. Totally what is it? 4 electrons will be there. Here the coordinate covalent bond electrons are given by the central atom. So the central atom is giving the coordinate covalent bond pair of electrons. This is what? 2 electrons that are shared. So oxygen 3 is not contributing any bond, any electrons for that coordinate covalent bond. Okay, so we can see all these atoms will achieve the octet. We talked about the ozone when we discussed about the coordinate covalent bond. But here the purpose is not to discuss about the structure of ozone. What is the purpose? The purpose is to find out what will be the formal charges on these oxygen atoms. So we are going to find out what will be the formal charge on oxygen 1, what will be the formal charge on oxygen 2, and what will be the formal charge on oxygen 3. Okay, so where do we begin? Let us begin with the formula itself. No, so what is the formal charge formula? It is the total number of valence electrons of the particular atom in the free state. All are oxygens only. No, what is the number of valence electrons of oxygen? 6. So accordingly we have to depending upon the oxygen, right, the other 2 terms will be changing. So where do we begin? We will start with oxygen 1, which is the central oxygen. The number of valence electrons in free state is what? 6 minus central oxygen. What is the number of non-bonding electrons? You see 2 minus half the times total number of bonding or shared electrons. See, here we have 4 shared electrons, here we have 2, because all of them are engaging the central oxygen. So 4 plus 2 is what? 6. So minus half into 6. 2 ones are, 2 threes are. 6 minus 2 minus 3, what is it? Plus 1. So on central oxygen, what is the formal charge we are getting? We are getting it as what? Plus 1. Now look at the oxygen 2, one of these end oxygens. The number of electrons in the free state is what? 6 minus the total number of non-bonding or that electrons coming from the lone pairs. What is it? Look at this, 2 plus 2, totally 4, minus half into the number of bonding electrons. See, the oxygen 2 is engaged in a double bond with the central oxygen, means totally how many electrons are going to come? Shared electrons are what? 4. So minus half into 4. 2 ones are, 2 twos are 4. So what is it? 6 minus 4 minus 2. What is it? 0. So on the oxygen 2, peripheral oxygen 2, what is the formal charge? It is 0. Now come to the oxygen 3. What is the oxygen 3 story? It will have number of valence electrons in free state is 6 anyway. Okay, minus what is the number of non-bonding electrons? All the 6 electrons of this oxygen are not used for bonding. It is not contributing any electron for the bonding, right? Because it is engaged in a coordinate covalent bond, correct? So which means what? We have to subtract what? We have to subtract minus 6, because the total number of non-bonding electrons, so minus 6 will come. Okay, then minus half into total number of shared electrons. See, it is engaged in sharing of how many electrons? 2 electrons, right? Only one shared pair is there. Minus half into 2. 2 ones are 2. So what is it? 6 minus 6 minus 1. So the oxygen 3 is having a formal charge minus 1. Now let us talk about the, so if you want to represent this in terms of the diagram, right, you know, how do we indicate it? So we'll keep the formal charge on oxygen. So whenever we see a structure like this represented, right, what it indicates is that the oxygen, central oxygen, is actually the donor atom for the coordinate covalent bond. So when you don't want to represent a coordinate covalent bond like this, right, we can just represent it like this, where we have the central oxygen given plus and the peripheral oxygen given minus. Means what? You know, it represents what? It represents that this one is the donor and this is what? This is the acceptor. So this is what is the significance of the formal charge. So whenever the formal charges on the atoms are negative means what? They are acting as the acceptor. Whenever the formal charges are plus means they are acting as what? Donors. Okay. So this is how we will represent the ozone with the formal charges. We look at one more example. What are the formal charges of each chlorine in Cl2? Again we will go to the formula. What is the formal charge formula? Number of valence electrons of that particular atom in the free state. So here they are asking, do it for both the chlorines in Cl2. See, if you see, right, the Lewis diagram, see, always we will get the formal charge from where? Lewis diagram. After forming one bond, right, both the chlorines will achieve octet. See, they are symmetric, right? So what we'll do is we can just calculate the formal charge on one chlorine. They are identical. So other one also will have the same formal charge. Look at this. Let us calculate the formal charge on chlorine 1 like that. Okay, so what is it? Number of valence electrons of the atom in the free state. What is the number of valence electrons? Chlorine. What is the number of valence electrons? 7. 7 minus the number of non-bonding electrons. See, chlorine is giving 1 electron for the bonding here. Remaining electrons are what? There are 6 non-bonding electrons minus half the times total number of bonding electrons. See, the chlorine 1 is engaged in only one bond. That one bond will be giving how many electrons? 2, right? So look at this, 2 ones are 2. So what is it? 7 minus 6 minus 1, 0. Chlorine 1, what is the formal charge? 0. Chlorine 2 is also what? 0. So this tells us what? Both the chlorines are giving equal contribution for the covalent bond. This tells us what? The electrons are contributed by both the chlorines equally for the bond. That is why the formal charges are what? 0 for both these chlorines. We can look at one more example. Let us say we talk about the diatomic oxygen or O2. In that, what is the story? Both these oxygens will share 2 electrons. Thereby they will form a double bond. Correct. Now each oxygen, what is the number of valence electrons? 6. Each oxygen, what is the number of valence electrons? 6. So it is giving 2 electrons means remaining will be what? 4 more will be remaining on both these oxygens. Now we have to calculate. So here also we can number them as what? 1 and 2. Of course, they both are what? Identical, isn't it? So look at oxygen 1, we will try to calculate the formal charge. What is the number of valence electrons in free state for the oxygen 1? 6 minus number of non-bonding electrons. Non-bonding electrons are what? Here 2, here 2. Totally what is it? 4 minus half the times number of bonding electrons. So it's a double bond, right? Double bond means what? Totally 4 electrons are shared. 2 ones are, 2 twos are. 6 minus 4 minus 2, what is it? 0. So oxygen 1 will have a formal charge of 0. Symmetrically, oxygen 2 also will have a formal charge of 0. Thereby what do we see? We will be able to see that the oxygens will be making equal contribution for the covalent bond. We can look at carbon monoxide. So carbon monoxide is another molecule where we have the coordinate covalent bond. So you can see you will typically get these formal charges when we have coordinate covalent bonds. So in CO, right, carbon will form a double bond with the oxygen. You can see I am putting the electrons of carbon as dot. What is the number of valence electrons of carbon? 4. What is the number of valence electrons of oxygen? 6. Okay. Now there will be a third bond which will be a coordinate covalent bond, for which the electrons are donated by what? Oxygen. So what is the representation here? We can see the triple bond, the third bond, right, is a coordinate covalent bond. It will be coming from the oxygen towards the carbon. So as a whole you will see what? After the formation of this bond, carbon will be able to reach octet and oxygen will be already in the octet arrangement. Okay. Now here we are not to verify the octet arrangement or anything. Here we are to calculate the formal charges on carbon and oxygen. Okay. So look at this separately. So let us calculate the formal charge on the carbon. So formal charge on carbon, what is it? Number of valence electrons in free state. What is the valence electrons of carbon? It is 4 minus the number of non-bonding electrons. See, carbon is having 2 of its electrons that are not used for the bonding. So which means what? Minus 2 minus half into number of bonding electrons. See, totally what is the number of bonding electrons? 6 electrons are there. So 2 ones are, 2 threes are. What is it? 4 minus 2 minus 3. What is it? Minus 1. What about the formal charge on oxygen? Oxygen, what is the number of valence electrons in free state? 6 minus The non-bonding, see oxygen is having non-bonding how many? 2, right? Minus half into what is the number of bonding electrons between oxygen and carbon? What is the number of bonding electrons? 6 electrons are there in the bonding, right? So means 6, 2 3s. What is it? 6 minus 2 minus 3, what is it? 1 plus 1 actually. So if you have to indicate this molecule with the formal charges, right, on oxygen will put plus, carbon will put minus, which means what? Oxygen is acting as the donor for the coordinate covalent bond and carbon is acting as the acceptor. Okay, so this is how we'll analyze the formal charges. And again, the formal charges will only provide so much information in terms of analyzing the coordinate covalent bond existence, but more helpful concept in understanding how the electrons are being shared between atoms is the concept of oxidation number or the oxidation state, about which we will study in further chapters. So this is the concept of the formal charge.